Hello everyone, welcome to today's video on physics. I'm Physics Michael. In this video, we are going to explore two important concepts, speed and velocity. These concepts are fundamental in kinematics and will help you understand how objects move. We'll also break down the differences between average speed, instantaneous speed, average velocity, and instantaneous velocity to give you a complete picture of motion. Let's dive in. Let's start with speed. Speed tells us how fast an object is moving, but it doesn't tell us anything about its direction. That's why speed is a scalar quantity. It only has magnitude, not direction. The formula for speed is simple. Speed equals distance over time taken. For example, if a car travels 108 kilometers in 3 hours, we can calculate its speed as 108 divided by 3, which equals to 36 kilometers per hour. We use the unit kilometers per hour here, and of course, if we use this SI units, the speed can equal to 10 meters per second. That's simple. However, you may notice that the car usually does not maintain the same speed. It may speed up or speed down throughout the trip. So 36 kilometers per hour here refers to the average speed. Now, let's talk about the difference between average speed and instantaneous speed. Average speed is calculated over a time period. It is the total distance traveled divided by the total time taken. In this case, the average speed of the entire trip is 36 kilometers per hour, but it doesn't mean that each moment in the trip it has a speed of 36 kilometers per hour. If we want to know the speed at a moment, it refers to the instantaneous speed. Instantaneous speed is the speed of an object at a specific moment in time. Imagine you are driving the car and you look at the speedometer. The number you see tells you your speed at the exact moment. This is your instantaneous speed, the speed of an object at a single moment or in over a short time. In this case, we can say the instantaneous speed at the moment is 18 kilometers per hour. It's pretty fast at that moment. Now let's talk about velocity. Velocity is defined as the rate of change of displacement. It is very different to speed. It includes direction, so velocity is a vector quantity, which means it has both magnitude and direction. The formula for velocity is change in displacement over time taken, or just use simple equation v equals delta s over delta t. Here, delta represents changing and s is the displacement. For example, in the case before, the car actually has a displacement of 54 kilometers due east from A to B, and it takes 3 hours. So its velocity is calculated by 54 over 3, and that is 18 kilometers per hour, and including its direction due east. It's just simply the same direction as the change in displacement in this period. Since velocity depends on change in displacement, not distance, so the speed and velocity of the car in this trip is not the same in magnitude. And don't forget that velocity includes direction, so they are very different. You may have noticed that we just calculated the velocity of the entire trip. It is just an average of the trip, so just like speed. Velocity can also be classified into average velocity and instantaneous velocity. Average velocity is calculated over a time period. It is the total displacement divided by the total time taken, while instantaneous velocity is the velocity of an object at a specific moment. Using the same case as before, the car's average velocity is 18 kilometers per hour. But for instantaneous velocity, think about a speedometer game, but this time with its direction. At this moment, the car is traveling 80 kilometers per hour, so its instantaneous velocity is 80 kilometers per hour, and including its direction of movement at this moment. And a moment later, the car is still traveling at 80 kilometers per hour, but with a different direction. So the velocity changes, even its magnitude is the same as before. Let's check the key differences between speed and velocity. Speed is a scalar quantity, meaning it has only magnitude and no direction. Velocity is a vector quantity, meaning it has both magnitude and direction. Speed is based on distance traveled, while velocity is based on displacement. Two objects can have the same speed but different velocities if they move in different directions. Let's go through an interesting example. Imagine a student is running with constant speed on the sports field. He completed 400 meters around the field in 80 seconds back to where he started. We can calculate his average speed by 400 divided by 18. That's 5 meters per second. But since his total displacement is zero, so we can easily figure out that his average velocity equals to zero. That's speed and velocity in average. On the other hand, the instantaneous velocity has a magnitude of 5 meters per second, but with changing direction at different positions. To summarize, speed is the rate of change in distance, measured as distance divided by time. It's a scalar quantity, so it has only magnitude and no direction. Velocity is the rate of change in displacement. It's a vector quantity, meaning it includes both magnitude and direction. Average speed is the total distance divided by time, while instantaneous speed is the speed at a single moment. And also, average velocity is the total displacement divided by time, while instantaneous velocity is the velocity at a specific moment. That's it for today's video. Thanks for watching, and I hope you now have a clear understanding of speed and velocity and the difference between instantaneous and average motion. I'm Felix Michael, and I will see you in the next video.